I'll put you on mute, Samina, or you can go on mute. There you go. Yeah, that was. Let me know. Just unmute yourself before you speak because I've kept all of you on mute. Uh, if you are not able to hear me, unmute yourself and tell me, or use the chat option. That's,
Yeah, I can hear you.
okay, so we will start. Okay, the first topic was today what we discussed Priya earlier. Uh, we were discussing about what to do during the interviews, and so these days, in general, they ask, they ask and they expect you to write some codes. So PySpark, which the link which I've shared earlier, go through them, make your SQL fluent around all the join filters, aggregation, and window function like lead, lag, dense, rank, all those differences. Get a hands on around those, because those are the typical interview questions, what they expect you to write and execute it so that they can see the output. That was one perspective. Second thing was uh, whatever you are putting on your profile. Let's say if you are putting PySpark on a profile, it's from a Spark perspective, you can expect question from, or you can expect question around optimization and debugging, and then some of these key concepts like suffling and partitioning, etc. And there's one more question, which is like they expect you to explain a use case which you have fixed in your day-to-day job or in your existing job. And that was something like you can take a credit for that. I along with the team have done this, and after that job started working fine. It had few problems, so you have to define the problem, you have to explain the solution, and you have to take the credit of it. So that's a one line of it could be your first question, it could be your last question, but this question in general comes if you say you have worked on Hive. Again, the lineup would be the same. On Hive, what you have done, and on Spark, what you have done, so that uh, I mean, what was the problem you have handled, and how did you fix it? That's a third set of question. So first is like practice, execute. They will give you a situation which would be mostly around uh, SQL queries. Get a fluency on that. SQL queries can be written in the Spark by Spark SQL. So better to get the hands-on with the SQL queries. It will help you in the Spark as well. If they ask you to write Spark, you can again do the same thing. You can write the spark.sql and write the SQL queries. And then optimization and debugging, which we will see. We'll try to cover up some of the points. Okay, so suffling and partitioning. Now, earlier, I think long back, couple of weeks before, we discussed that uh, partitions are the core on which the Spark works. Okay, so if let's say you have 1 GB of data, and you have a Spark cluster which have let's say n number of executors, those 1 GB of data will be distributed in chunks. You get this option to decide what would be the size of that chunk, and it varies from 128 MB till 2 GB. So you could have you had 1 GB of data, you can have one partition. That's also fair enough. Or you could have two partition of 500 MB, 500 MB, or you could have four partition 200 MB each, or you could have eight partition 128 MB each in general. So that's called the logical partitioning. But logical partitioning on data, it's always when you understand the data, how you are doing it. So we'll take some examples that what could be the problems around it. But partitioning, we know, right? From the SQL perspective, if we talk about when you partition your table, what do? You do it on the, let's say, year. So you create a table and you say that it's partitioned by the date column, and date column extract year from this date and partition this table. So year, let's say you have 10 years of data, so there would be 10 partitions. Every time you write the query and you put in the filter clause where year is 1919, or sorry, 2019, it will go to the 2019 partition. So your query performance gets improved, right? You are not looking, you are not looking at the complete data set. You just move to the right folder and you have just scanned only the 2019 data because you have put that on the where clause. So based on the query and query pattern, and based on the data set what you have, you decide to partition it so that all the partition would have the equal amounts of data. In general, should have the equal amount of data, so that the query performance always uh, be the same. It should not be like for 2020 you are, let's say for 2019 you are executing a query and that's taking uh, 200 seconds, and in 2020 if you are running the query because you have the lesser data, it's taking only few seconds. It could happen, right? Let's say 2019 entire year the market was on, you had lots of data on your DB. Your partition was on year. So 2019 bucket has lots of data, but in 2020, let's say we have faced the lockdown, or we we didn't had that volume of data. So let's say it has lesser number of records. So, so performing queries on lesser number of record will be faster. In these case, this is a perfect example of data skewness. We'll come to that point, but before we are still trying to understand the partitioning. Okay. So what we can do, we can create a, it was created earlier, I guess. It was created earlier under the hood, 100 GB to 2 GB partition. This fair enough. Let's do it one more time. First, we'll understand the partitioning concept, and then we'll understand it from the uh, Spark perspective. So we'll create some data.
Keshav, are you sharing the presentation or some other screen?
I'm on to Excel.
No, we are only able to see the presentation slides.
I'm sharing it again, then stop sharing. And okay, now do you see the Excel?
Yes, yes.
Okay. So I'll get some data first. Let's see. Instead of creating the data, let's copy it from some. We'll use this data, but I will just get rid of the things which I probably won't need. So delete this, lat long and etc. Not needed now. Minutes remaining period, playoffs, season. Seconds remaining, short time. Team ID is needed. Game date and this. You can still consider this as a just a dummy data, but we are trying to I'll just make some modifications so that we can understand this. So let's make it 2019. Okay, so now this is our data, and believe me, it's like it's going till in millions. And uh, client understanding, okay, which is like 1 million rows with prox 100 columns. And columns should be something like this, not like big columns with 100 varchar size of something. Is approx amount 1 GB in CSV format. So 1 GB data, 1 GB data means million of rows will be there at least. And if it has 100 more than 100 columns, we call that wide table. If it's lesser number of columns, we call it narrow table, narrow data set. So approx or less than 100 will be of size of 1 GB. That this was just for the understanding. Okay. Now on this data set, by looking at this data set, let's say this data set is given to us, and we'd like to do a partitioning on this because it's a millions of data set, and we don't want every time our queries, let's say even if we are doing the select star from this table, we don't want every time this to be scanned. Normally what happens when you query a table or query a data set, which is CSV or etc., everything is scanned, right? It's a search and sort method works. So if you talk about database is technically a very optimized search and sort mechanism. Search and sort mechanism, right? Because you fire a query and database engine, so database engine start scanning all the data and sorting it so that I can give you the right result. Let's say you have written a query, select star from this table where uh, action type is jump sort and date is this, or sort ID is 4. So what database will do, it will start scanning everything. It will first fetch all the records which is of jump shot. In that jump shot, it will start looking for this column. So it will have database engine always prepare a query plan. Now, so your DB engine always creates a query execution plan, and Spark also does the Spark is also a DB engine or query engine. That also creates a query execution plan, how this query will be executed. But Spark is not like a black box. Oracle, MySQL, Postgre, Teradata, they all are like black box. How they internally do, only when they publish the what they write on their white paper, we only know that much. We don't know the if they are doing anything else more optimized than that. But in Spark, the things are clearly written. The tweaks are given that these are the ways in which you can optimize your query performance. So Spark, that's why has a very importance, that it gives you it always in your hand to optimize it. In database, normally query optimization, if people ask question from database perspective, you can say I can apply the indexing on the column, I can apply the partitioning on the column, I will see the query plan execution. If the query is not written well, I will optimize the query. That three answers suffice. So a black box kind of database or query engine. But in Spark, you have tweak at every level. If optimization question is coming to you related to Spark or Hive optimization, how will you structure your answer should be in these four categories. First is the storage, data storage. How you are storing your data on the storage data storage pattern on HDFS. I'm saying HDFS, that means any distributed file system, be it S3, be it Azure Blob Storage, be it Google Storage, any cloud platform or any Cloudera distribution platform, Hortonworks distributed platform, or a vanilla HDFS. How you are storing your data? You are storing your data in Avro, you are storing your data in Parquet, you are storing your data as a row, as a normal table, CSV format. You're keeping everything in the CSV, or you can keeping everything in the JSON. We had discussed this earlier. So the first attempt is that you will explore or you will optimize the storage pattern, because if a storage pattern is optimized, you will always be looking into the right self. Remember those packing and packing example, that in suitcase you placed different object, and then when you are unpacking it, you have to look for a particular object. So either you pick the entire row, or you just go into that column what is needed. You are looking for the socks, you'll go for the socks column. You are looking for particular data, you will go in that column. So storage pattern optimization should be the first thing. Second comes the data processing optimization. How you are processing your data processing optimization. Now processing has in processing, you might be using Scala, you could be using PySpark, you could be using Java, you could be using Spark, you could be using SQL, you could be using any programming language. Programming level language, at that level also you can optimize. PySpark in general, earlier it was relatively slow than the Scala, because Spark had the native support of Scala, and then it had the benefit. So most of the Spark project on production, you will see still uh, most of them 60 to 70% are in the Scala. Earlier it was like 100% Spark project were written in the Scala and on production. Now PySpark is picking up. So language, then tool, what tool you're using. Let's say if you're using Databricks, if you're using EMR, if you're using in Azure, we have Synapse or Data Factory, etc., etc. So what tool you're using, that also gives you the edge. So first is the language, second is the tool, third is the query you write. How well is your query is structured, what you are doing in your query. So in process at the processing side, you try to optimize the data processing and compute. number of executors, how many executors you have, what the bandwidth, bandwidth, by bandwidth I mean how many executors, CPUs are available to you, what is your cluster sizing, and etc. But I will come to that later. But in processing, those things are also involved. So the second step you will take, we will talk about the data processing optimization. Then it comes data concurrency. How concurrently you are able to process your data. Let's say if 10 people are firing the same queries, is your database is still able to respond? Let's say 10 people has asked the complete data at the same time. So what will you do in that case? So concurrency optimization is also needed. You have to ensure that the queries which is being fired by them are well distributed, and you have optimized. So with concurrency, there's two ways. Okay, so I will just write it. With optimization, I said you first check the language in which it's written. Language. In second, I said tools, what tools you are using. Third, I said the query what you have written. Now it comes to the concurrency. So the queries you have written, are these optimized or not, that you have handled. In concurrency, you will check that data is well partitioned, no skewness, and third thing I was about to say, then I forgot. Concurrent execution of the same data set. Oh yeah, remember, got it. Read write optimization, read write process. Okay, so you have a query. Your query would be of two type. Either you are doing a select, or you are doing an insert, update, etc., or delete. Right. So when you do insert, update, and etc., you do the write operation on the DB. So some of the database can be specifically optimized if, let's say, you have your serving layer comes in picture with the concurrency. So if you are making your, I think you remember this diagram. If not, let me just pull it up so that concurrency can be understood. Concurrency is important because today's topic is that. And in the document, this layer, you understand, right? That this was the storage optimization, this was processing optimization, and tier 3 what you have written. Tier 3 is optimized for the concurrency. At tier 3 level, you use some technologies like Aurora or Cosmos DB, which are specifically meant for the read only operations. So all the reads from all the users can happen pretty quick. They are read optimized. So that was the idea I was trying to bring in here. That where did that slide go? Read optimized or write optimized. Now read optimized and write optimized, you can have very well segmented. You could have 50-50, that it will give you the 50% 50% preference towards read, 50% towards write. Or you could have 80-20, that 20% preference towards the write and 80% towards the read, because you are on the third layer where the read will happen more frequently. So your executor memory and etc, you will plan it accordingly, so that you you will do you will take steps so that your data is read optimized more, and let's not create any hotspot, or let's not create any hotspotting is a concept, so we'll discuss, but let's not jeopardize any read operations. Insert write queries can wait for some time. I will write it and then I will return back. So you will do the asynchronous query for the write, and read will be synchronous. Or it could be if, let's say, if you could have requirement like this as well, that from the UI you are only doing the write operations, you are not doing the read. So this is important when it comes to the concurrency. Your table should be well partitioned, no skewness in the data, and whether you are doing the read optimization or write optimization, that you have to understand this percentage distribution of them, and then accordingly you take the action. So this was the three key. Any optimization question from now onwards, I would expect that you frame your answer in. I don't want you to repeat like exactly the same way, but step by step conclusion is always very important in the interviews. Question is asked, which is very generic. For any generic question, if you explain random answers, this can be done, this can be done, and etc., then it never concludes. It never gets the conclusion. So take this methodology, that you explain it segment wise. First, you will tell them that these are the segments in which I need to look, and in this each segment I will look at this particular area. If you will be that structure, interviewers will understand that, okay, yeah, you understand holistic way of optimization. Any questions so far? Obviously, the fourth one, why this space is empty.
You're breaking, Keshav.
Yeah, you're not audible.
I'm breaking.
Which fourth one?
No, I'm not saying anything. I was just color coding this. I was taking a pause so that I can
Mm-hmm.
hear from you all. But
Okay.
you can hear me now, right?
Yes.
Yeah, I was not talking. I was not speaking. So don't worry.
Okay.
Fourth is still before moving to the fourth. I said let's give it a right quick check, because this looks like quite important,
Mm-hmm.
and I can use it later as well. Okay. So fourth one is towards, you can keep it towards the infrastructure. Okay. Despite you do whatever it takes, all you have done the storage optimization, processing optimization, concurrency optimization, you did everything, and your infrastructure is just like a slogging piece of stuff. Like you just have two executor. Believe me, I mean, you're just working on community edition. You don't have a rightly scaled Spark cluster. What could you do? You can't do anything, right? So after applying all these sort of techniques, you then you come to the infrastructure. Because see, normally this is a big mistake what people does, that they start, whenever a optimization question comes, people start optimizing. Oh, I'll increase the executor, I will increase the CPU, and etc. But is it in your hand? You cannot increase it. You have to take the permission, the Spark cluster, the machine will be bought, or the machine will be scaled, the infrastructure team, admin team will uh, be involved. It's not something which a developer can do, but developer can recommend. So your answer, most of the answers what I hear when I take interviews, I ask for the optimization, and people start saying that I will increase the executor, I will increase the CPUs, and my processing will be faster. I will uh, do this what is called compaction. serialization. These are the processing layer of the optimization. Okay, so I will read less data by zipping it or using the cryo serializer and etc. But that's not infrastructure scaling is not in your hand. It should be the last option you have to recommend. And infrastructure scaling, where you increase.
Keshav, are you writing something in the Excel?
Is it
Are
not
you typing?
visible now?
No,
Yes, I'm writing in the Excel.
no, it's not visible. It seems like your screen is freezed.
I'll reshare it.
Okay.
Can you see it now?
Yes.
Excel with this, yeah. Okay. So I'll just code it to the green, because this is something you need to answer at the end. And at the end, you have limited. I mean, you will just recommend that scale your infrastructure, scale your infra. That means add more nodes, and each node will give you more CPUs and memory, and your Spark is sorted. But believe me, none of the interviewer is interested in this answer. You have to frame this either well, or you have to explain this at the end that I've tried everything, and then at the end I'm recommending this to happen. Okay. So these four patterns, you ideally you should remember. Okay, now let's copy this sheet. Move and copy. Move to the ends. Create a copy. Okay. Sheet one, sheet two. Now let's remove everything. Now we'll go back to the partitioning concept. Okay. So this was the data set. Now, by looking at this data set, from DB perspective, we understood that you pick a column and you partition it accordingly. So there is one way of partitioning, which is like you identify a key based partitioning, and then hash based partitioning. Now, key can be composite. Composite key, right? I'll mix these two, action type and game event. Those two become the primary key for this table. If later this is not working, I will add third column logically. Okay, it should not be like random that I'm just adding the columns and then making it composite key. So composite key can be like the set of columns, and which can signify the uniqueness in data. And when I mean uniqueness, like if I'll put this composite key in the where clause, where this is this, my DB engine always will come to this right column, right row. So you have technically, what are the concepts? Primary key, right? Primary key is what? Primary key is should not be null, should not be null, and always unique. will not be replicated. That's the property of the primary key. So composite key, you pick the number of columns based on which you can enforce this behavior of, like, there's one way you write select a star from this table and where sort id is 5, it will always come to this, right? But on primary key you cannot partition it. Primary key is continuous variable, it's always unique. And if you create a partition, one will have one table, two will have two tables, so it will take the similar amount of time by scanning all the folders. What happens in the windows. Wait. Okay, sorry. Sorry for the disruption. So let me know if you have question to understand the composite key. But technically, composite key is like composition of multiple keys. By keys, I mean it could be any columns. The idea for the composite key is to have the uniqueness, to ensure the uniqueness in the data. If somebody will write this in the, let's say these three columns are composite in nature. Composite, by these three columns you can identify the rest of the data. So it can be the way you can do the partitioning using these three columns. Okay, sorry. uh, there's one thing which I've said is wrong, which is like, uh, the composite key, based on composite key, obviously you will not do the because if composite key will be of primary in nature. So composite key will, based on that composite key, you can understand this skewness, but you cannot partition it based on that. So you have to understand the key, which has a statistically, if I'll add a column, let me know, because I was a little wrong earlier. When I said composite key can be used for the partitioning, no. Mm, please don't. If you have any doubt, ask it now. Uh, what I was trying to say, key based partitioning is like you have to identify the variance of every data set in that particular column. And let's say the best part is this month. Sorry, this year. Now this year, date column always qualify for partitioning. So you can make it as a date key partitioning, for example, or gender, or let's say if this would have had the gender or something, or this could have had the status. So active, pending, pending, closed, active, pending, closed. And on this game date, you can also derive the column called month, right? It could be in the Jan, could be in the Feb, could be in the Feb as well. It could be in the March. It could be in the Jan, August, August, Jan. Let's say, sorry, these are all Octobers, but let's say I'll just change it. It should be 01, should be 02. And there's no 31st, so let's say 28. 18 is fine. Just again 02. Let's say pause on my end. If you have any questions, ask. August 08. And I'm preparing the data. 01. Okay. So for partitioning, ideally this is a right candidate. Then you saw, okay, this has the gender as well. Let's say when you move to a project, they were using this as a partitioning logic. They were partitioning the data set. When they are partitioning the data set, what we mean is you pick the column, and then let's say this was your data set. In this, you have identified this date column, and then this data got partitioned into the based on the date field. So now you have three separate data sets. I'm doing it because I'm trying to make this large. Okay. Now let's say the date was in let's say this is year equals to 2018. Over here, year equals to 2019, and this is, let's say, 2020. Let's say for the God sake, 2020 was a good year. And we have some let's say more number of rows in the year 2020. Then we had just 2 rows in the 2019, and we had some number of rows in the 2018. So this was your original data of, let's say, 1 GB size, for example. You applied a partitioning on date column. So date was identified, it was converted into the three different data set. And now you are writing a query, your select query, when it is hitting the DB engine, it gets it understand that you have written here the where clause, and based on this where clause, it will either scan this, or scan this, or scan this. That's the idea of partitioning. It can be so till this point, if it's clear, this along with this year, you can also use some other columns like gender. Let's say you have first made gender a column. So the same data set. I hope this whiteboard is clear, right? I'm again sharing a different screen, so let me know if this whiteboard is clear or not. Oh no, so it will have this volume of data in the mail. will have this volume of data in the female, and then this will get further year wise optimized. We can have this sort of logic, right? This is male data, male partition, this is female partition. It was easier for query, right? First it will resolve the what is the gender, then it will go in this flow, and in this flow also ultimately it will be, let's say this is 2018, so, and this is 2019. So I will be just reading this a small piece of data. Believe me, the query performance, the level of the optimization I can expect from this query performance. Or sorry, the understand the level of performance improvement by doing this optimization. I did some optimization. I just changed the partitioning logic, and then my data was my query was always reading the smaller segment of the data. Scan time was less. Read is always read and write is the expensive operations, right? I'm reading a smaller set of data, so I will take less time. Instead of reading the entire data, instead of reading this, I'll take lesser time. Clear? Overall partitioning logic is understood now. Now we'll come to the Spark side of partitioning. Spark does the same thing. It just that we'll understand from this Spark. So the same thing happens in this Spark as well. But what happens in a Spark? You have the Spark cluster. So you have the Spark master. And you have multiple executors. Every executor has its own set of memory. So in Spark, partitioning becomes very important because it's not on the on the same machine you can do male, female, and year wise partitioning. But believe me, in Spark, on every node it will be partitioned accordingly. Okay. So typically, what happens? Unless you know the entire data set, sometimes this guy becomes huge. This is let's say a huge partition. Somehow all the male and all or either all the females in 2019 has come to this partition. It could happen, right? That let's say this is all females and 2019 data, and this is huge. Every time you will fire this query, and let's say this is 2020 data for all females. So if this partitioning logic is not correct in Spark, this could have further implications, further scan performance issues. Like reading this data set, it will give you, let's say 100 seconds, and while reading this, it's giving you 10 seconds. So customer will come up with the problem. Customer is saying that sometimes my query works within few seconds. Sometimes it's taking 100 seconds, like to approximately 2 minutes, right? So what is this problem? And I've kept it in the seconds. Let's say if this is 500 seconds and this is 50 seconds, 10 times explosion, right, is happening. 10 time explosion means reading this lesser volume of data, the query resulted faster. Larger size resulted slower. So the idea I'm trying to bring in here is that over here in Spark, you have to be you have to understand the data well, so that you can create the right composite key and equally distribute the data, not like this, which is like a skewed data. So you have to remove the skewness from the data set. Skewness means this data set is large, this is small, this is small, this is large, this is large. So this is not equally distributed. You have to work with the equal distribution. The logic of partitioning is always intended to have the equal partitions. Okay, so equality, how will you ensure that this is done? So we talked about two methodology. One was the you have to identify the right set of keys, and you'll call it the composite key for partitioning logic, not for primary key. From the primary key perspective, let's remove this. You'll identify the composite key for your partitioning logic. So you will identify the composite output columns, because even if you search composite key, you'll get the different definition composite columns for your partitioning logic. That's one way. Second is hash partitioning. You identify you what you technically do. You create a hash for this entire rows. You can that's a worst case situation. Every row is different, right? And you created a hash for it. So and you created a hash registry. Every time you'll fire the query, the hash gets understood, and you'll go to the right executor where the data is present. So hash partitioning is like you can generate the hash for your composite key or for individual columns, individual columns, and then you club them. So idea is, again, with the hash partitioning, the hash values, master will know the hash value of every record, and when it's distributing the data set to the multiple executors, it will keep a track on the hash code. And when you ask for a particular row, your where clause gets converted into the hash to hash matching will happen, and you will get the right result. This is the concept of Teradata or Snowflake. Okay. So you could ask question now or later, but let's say if these three columns I've identified, for these three columns, let's say I will add a insert, I'll add a hash column. So let's say for this is the value, so same hash will be created. I think the others doesn't have the same value, but let's say if for this row, I'll keep the value as same. So this hash will be designated to this column as well, and this will have different hash. This will have different hash. This will hash means encryption for this logic, which is irreversible. So what will happen then whenever you fire a query and you get this hash, you know that where this data is located. Your master knows this where this data is located, and it will run your query against that executor, and you will get the result faster. So it will not, in fact, spend the time in looking for where all these composite keys are distributed. At the executor level itself, you have done the hashing. So let's say for you have, okay, now there is a question. Let's say you have more number of hashes than the number of executors. It's obviously true, right? You can have maximum How many? Executor means every data node. You could have 16 executors. But you have generated, let's say, 32 hashes. For simplicity, I'm saying. So 2 hash each executor. Still the master knows, first master will resolve the hash and then it will direct you to that segment. So hash based partitioning is internal white paper of the Teradata and the Snowflake. It was earlier, it wasn't existing in the Spark, but now they have also introduced the hash based partitioning, and Spark performance is like Teradata or more than that, because first you resolve your executor, and your executor should not be very random, that suffling and partitioning and etc is happening, and then you never know that where your data is. But in Teradata and Snowflake, master always knows where the data is, and it will first resolve that, then guide you to the right place. That sort of coordination is needed, which is very much in the Teradata. They are from the same. Snowflake is from the Teradata itself, so they use internally the same execution pattern, and that's why Snowflake is these days are the leading, despite of all the industrial standard of database. Snowflake is leading in terms of all these way of optimization. Okay, I hope partitioning is clear now, right? Anyone?
Yes,
Or
Keshav. And what about this short made flag? I have learned partitioning from this flag concept.
no, these were just a column, right? I mean, see, let's say I'm not considered. If you want, you can consider this. What I said is, like, I consider these 3 columns for doing the partitioning. And I picked it up. If you want to do this short made flag, I mean, yeah, it has 0, 0, 1, 0, or null value. So you will have 3 partitions. You can include this, yeah,
Okay.
at the top level. You can also include this to be your composite queue. This is what you have to understand from the entire data distribution. Let's say now you have 50,000. If it's equally distributed, let's say 30, 30, 30. 0, 1, null. So null comparison you can't do, but at least you will be guided to the right executors. You will be guided to the right logic. Yeah, if you want, this is a perfect example of like the gender what I said. Instead of me introducing gender, I could have used this. Yeah.
Okay.
So the idea of partitioning is to make your partitions, every partition, easily distinguishable, so that
And
your
equal.
query just run and scan only that set of data, only that number of rows. Clear or no? Okay. So now the partitioning is clear. Now let's talk about the suffling. What could be the problem? You have a master. A master node, and you had a couple of executors. So like you said to okay, earlier I didn't consider this column, but you came to the team and then you identified why not you are doing the partitioning on this column.
Mm-hmm.
Let's say you have raised this doubt. I said yes, yeah, we can do that. We can consider this. This could be a right candidate. So when you do, when you add one more column,
Hmm.
okay. So what will
Sorry.
happen? Data.
When we add one more column.
Let's say we had. I was naive, and I have done only partitioning on these four columns, or let's say just three columns. Has is the additional one. Huh? So I have done the partitioning on these three columns. You said let's introduce this as well, and this will improve the query performance, and then you will see the benefit. I said, okay, fine. So I will introduce one more column for all the partitions. Right. Sort ID will come. What the master will do, then earlier the data was sitting on these nodes based on those three partitioning logic. Right. It was based on the logic of these three columns: short action type, action event, game ID, and etc. You added one more column, so master will have to reshuffle it. Just wait, somebody is at the door, and then there is storm. Every day in Delhi, it's just there is storm. I don't know what has happened. Okay, so I don't know what has happened to the nature here. It's like every day from last 3 days, I'm saying every day at this time some sort of storm, cloud, rain, and this is June in Delhi, which is like it should have been hotter. Just give me a minute more. Okay, so I was on the whiteboard. Let me know if you see. So I was talking about reshuffle. First shuffle and then let's say reshuffle. So shuffling means the data from this, all the executors will be again distributed again. It will be distributed again. So data from this partition might go to this. So this is a logical way of reshuffling in which you have introduced one more query, and there was no option from master than to do a reshuffle. But initially, when you create the partition, like I said, I'll take an example as well. So partition is what? Partition is like logical segment of data, and data is data in itself is like the entire data. Entire data. The logical segment of entire data. Logical segment of entire data can be partition based, can be size based. So it can be partition based. I mean, partitioning logic based rather. The partition logic which you have earlier, I was just using 3 columns. You said include fourth as well. So partitioning logic had changed. It could be partitioning logic based. It could be size based. Earlier, let's say I was doing 128 MB of partitions. I had 1 GB of data, and I was creating like 8 partitions of it. You said why you are creating 8 partitions? Create just 4. Let's increase this to the 512 MB. Okay. So partition logic, you added one more column, and the suffling happened. You also recommended that 128 MB size partition is not perfect for this data set. Let's increase it to 512 and then see the performance. So okay, yeah, let's do it. All right. And you have suggested these options by doing 3 things. So what you did, you evaluated how many executors we have. How many CPU each executor has, and the size of data. This could be another explanatory option for you all in the interviews. Why is we will talk about, but structure. Please remember the structure when you explain. Okay. So let's say this could be one of the good example that you joined a company and you were saying that their partition logic was completely skewed. I mean, it was like it was not correct at all. That's why they were seeing they were facing the problem of some queries were running faster, some queries were just failing over the weekend, some queries were running quickly. So they had this pattern based issues. So what I did is like I me being new into the system, all I had the option is to understand their data and then their infrastructure. So based on the infrastructure and the data, what I did my analysis was like first I checked that uh, how many executors they are using. So let's say they are using 16 executors, and each executor has 5 CPUs. Technically, let's say my computer has 7 CPUs. So you have 7 CPUs, and you have some set of data. Let's say you're dealing with 1 GB of data. Technically, I should make it more, but it's an example, right? So imagine you have enough infrastructure, still your stuff is failing. Sometimes it fails because your partitioning logic is not correct. Spark Master does spend a lot of time in shuffling the stuff from one executor to another executor. The way you write the query, your query execution patterns are not correct. Okay, so you 16 each 16 GB of the RAM, each executors, 7 CPUs, and you are processing only 1 GB of data, and still you are facing problem. That's a one set of question. Sometimes interviewer will give you this option that I have enough resource, and when they mean enough, they mean something like this: they have 16 GB each and they are processing 1 GB of data, and that also is taking a couple of minutes to complete. Technically, Spark should finish it easily. But what you have done, your 1 GB data set, you are distributing it into the 8 partitions, right? If somebody could change this to this, it will become 4 partition, or rather 2 partition, and each partition can fit into the one executor. Somebody can also make it one partition, and this one partition can also fit into the one executor, can be executed. You don't need much partitions here. Your data set is less. That's one example. Agree if you have understood. Okay, now let's say this becomes 100 GB, and you have the same each executor 16 GB. You cannot just go with this pattern, right? Increasing the partition size. You have to apply some other logic. Decrease the partition size, process it, pull the next volume, process it, pull the next volume, process it. Now you need the parallelism. Parallel,
This
parallel.
concept was explained in your first class. Is the same concept you're explaining?
This concept is being used in all the DB,
Okay,
but
okay,
in Spark you have these options to tweak.
okay.
You can set this partition size, and when you
Mm-hmm.
set this partition size, what could be the problem is important to understand. This happens technically. I mean, Oracle and MySQL and Postgres doesn't give you the option to decide your partition size. They decide it dynamically by themselves,
Mm-hmm. Okay.
and they have all Postgre is now horizontally scalable as well, and it's not like a Spark, because why I say Spark is Postgre is a complete solution. So it will not allow you all those configurational changes because they are
Mm-hmm.
selling their product. Spark is allowing you to do all those configurational changes, which Database has done.
Okay. Got it. Hello. Keshav, you're not audible.
Hey, I think my internet has gone down. I've connected from my phone network. It will not work that efficient. So I think we would have to drop in another 2-3 minutes because the internet router is blinking red. I don't know, because of the storm, I guess. So what I was saying is, let's wrap it up for the day. Uh, can you see my screen? No, right?
No, Keshav.
No. I'll try to share again. I'm connecting from my phone internet. Okay, so partitioning and suffering logic is, to extent, uh, should be clear, right? If it's not clear, let's take those questions tomorrow. But please come
Shuffling
up.
logic is not clear. Not clear to me.
Suffering is
Partitioning is clear.
okay. So suffering is still not clear. Okay,
Mm-hmm.
we'll take that up tomorrow. But suffering, believe me, when you call some of the methods,
Mm-hmm.
like you make changes related to the size of the data, and you decide this 2 GB partition should be 3 GB partitions, and etc. Or of
Mm-hmm.
course, 2 GB is the limitation. You cannot increase beyond that 2 GB.
Mm-hmm.
Logical distribution of the dataset should happen within the range of the 2 GB. But if let's say it was 128 and you have changed to the 512, then you have the option to play in the range of 128 to 2 GB. And when you do that, the master will shuffle the data. Master will shuffle the data in the query execution as well. Like when you do the join, data has to be brought from this partition to this partition because you have to do the join. You can specifically call the repartition strategy when you suggested that change the size from this volume to this volume. That is called repartitioning in Spark. When you
Okay.
call the repartition, you'll execute the shuffle. When you call, I think Kules does the executor internally. So when you do the join operation, when you do the size changes, when you make the changes in the partitioning logic, the shuffling operation will happen. And by shuffling, I means the data from this executor might go to this, some data from this executor might come to this. Shuffling of card, like you remember, right? You try to shuffle a card a lot so that the randomness can be ensured. And randomness over here, it's not the card game. So your randomness should be very well predicted. What is your randomness you are trying to introduce into the system? So your partitioning logic is your randomness, and shuffling is like you're shuffling according to your partitioning logic and size.
Okay.
Okay.
Mm-hmm.
Mm, Now the next thing is, I think we could also discuss these pain points, joining two big tables. Let's connect tomorrow so that we can target three things. We can target some of the common errors and these interviews questions. But yeah, come up with the questions now so that I can explain, because I don't know, somehow I go into the very detail of one topic and then it takes all the time. So let's target it tomorrow. The
Okay.
interview.
Can we do the shuffling hands-on tomorrow?
Okay, suffering you
Because
won't
I
get
have
to
never done
you
shuffling.
you won't get to see. Okay.
Okay. Mm-hmm.
No, 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 no. You can see it from the
Polish.
Spark UI. Okay, we can do the hands-on on the data big. I think
Mm-hmm.
split waiting on the log. Shuffling, yeah, shuffling hands-on. If you want to see, we can try it.
Okay.
What you need to do, I'll tell you the logic. What you need to do is you first decide your partition size. Okay, 128, or start with 128. Then you check and you put the repartition 8 8 or something.
Mm-hmm.
Then later in your code, you execute some queries and then you introduce repartition 16. Same data will be executed in the same 16 executors. We will see that. Okay, yeah, that's that we can see it practically, but theoretically, if you have any questions, that's another thing.
Okay. Theoretically, it's fine. Tomorrow we can continue with the shuffling and partitioning practicals.
Sure.
Okay.
So, so, but yeah, tomorrow I'm also planning to conclude that interview topics. Like
Okay.
joining two big table is a very important question in
Okay.
Spark.
Mm-hmm.
Technically, this is one of the question which is a hot topic in during the interviews. They will give you like I am joining two big table. What Spark will do?
Okay. Mm-hmm.
That's a key question. So I would like to just give a theoretical coverage, and then on the hands-on, yeah. After that, we would have nothing much to do. Just the hands-on is remaining. But for the hands-on, technically, you will not be blocked for your interviews, right? So let's cover it up as much as we can theoretically tomorrow, and then with the time we can see the hands-on as well. And for the hands-on, like I'm telling you the logic that you just do the repartition on your data frame, and you specify the number of partitions. So if you specify, you initially in one line you specify your data frame to be repartitioned at 8. Later you do the repartition at 16. So there would be 16 partitions will be created. That's the
Mm-hmm.
logic. We will see the hands-on. We will see it. But tomorrow, let's target it from the interview perspective. The two big items, debugging and joining two big tables.
Okay.
Okay,
Mm-hmm.
perfect. Then thanks all. It's because of the internet issues. I don't know if tomorrow this time how it would be the situation. But yeah, we'll join tomorrow, same time.
Okay. Bye bye. Thank you. Thank you, Keshav.
Thanks
Bye.
everyone.
Okay, thank you. Bye.
Thanks.
Thanks, Keshav.